Hello everyone, I am Kirtana. My team members are Arpita and Amrita. Here we are going to present our mini project which is named as climate data visualization by using Python and under the guidance of Gautam sir. The next part will be continued by Arpita.
Hi, myself Arpita. I am here to introduce our topic called climate data visualization. Our environment is changing rapidly due to climate change and while large amounts of climate data exist, it can be hard to understand without proper visual tools. So our main goal was to simplify and visualize climate data for different cities in Karnataka to help users understand temperature, rainfall, and seasonal trends clearly. And here we can understand it's climate data. It refers to recorded information about the Earth's climate system collected over the time. It includes measurements and observation of various atmospheric, oceanic, and land-related variables. And the next part is continued by Amrita.
Next part objectives to collect real world climate data, example, temperature, CO2, rainfall, etc. To analyze the data and find the meaningful trends and patterns. Then create the simple and clear visualize like charts and graph. Raises the awareness about the climate change through the visualize. Next part will continue by Kirtana.
Here we'll see the software requirements, what we need to for achieving this project. Here we have used that operating system we have used is Windows 11 and the programming languages we used is Python of 3.x version. And the platform we have used initially Google Colab, then we moved into Visual Studio Code, and we have used the Python libraries like pandas for handling the data, matplotlib, cbar, and plotly for visualization purpose. And we also used NumPy library for numerical operations, some kind of calculations, and
Like here, next topic is about the visualization module. This visualization module is the core part of our project where you transfer raw climate data into understandable visuals using Python libraries like Seaborn and Matplotlib. Where the module generates line plots and trends graph for the following climate indicators, shows how the temperature in each cities has changed year by year, helps detect warming trends or unusual patterns, and rainfall trends. Display annual rainfall data to monitor changes in precipitation over decades, useful to study effects like drought and or increased monsoon activities. And CO2 emission trends illustrates changes in carbon dioxide levels linked to urbanization, traffic, etc., indicates air pollution levels or contributes to greenhouse gases and city-wise focuses. Each graph is generated per city based on the user's selection, enables personalized locational specific insights for cities like Bangalore, Mysore, etc. And the next part will be continued by Kirtan.
here we'll see the what is there in the coding and implementation part. We have in this we'll see the programming languages we have used and the libraries. The language which we have discussed earlier is the Python we have used of 3.x version, and then the libraries we used pandas for large amount of data handling and NumPy for mathematical calculations. Then the NumPy which is mathematical calculations, and the cbar we have used for plotting graphs, and matplotlib is same as that of the cbar for visualization purpose. And we also used markup languages like HTML, CSS for styling purpose, and Flask is the language which is for the backend development. And then we'll see the description of major functions that we have used in our code for achieving this project that is named as climate data visualization. Here we will see the major functions like check file name, which validates that if the file is exist or not. If it is not exist, then it will be shown as a print error message. There is no existence of that particular file, and you'll see that pd.read csv, which loads all csv file data of climate data set into the data frame. And then the np.random choice, which assigns this random function which assigns the city randomly uniquely. And then sns line plot, which draws the city wise line graphs. And next we'll see the code. Here the main code we have used is, here we'll see importing. Here we'll see the source code of this project, which is helpful for achieving this project, climate data visualization. In the main code, we have imported some kind of libraries here. The main theme of this, we have used Flask app here. The main theme of this app is the Python Flask app, which displays the climate data like temperature, rainfall, and CO2 emissions for Karnataka cities. and also generates the plots dynamically when the user selects the city and displays these plots on that particular web page by using the HTML and CSS. And after that, the code breakdown will be done here by explaining the line by line code. Here we have imported some kind of libraries and all. For example, import OS, which helps work with the file paths to load that particular data file, and used to create, and the IO, import IO, which means used to create an in-memory buffer for image saving, and also base 64, which converts that particular plots to base 64 so that they can easily embedded in that particular HTML web page. And the pandas is used for large amount of data handling to process that particular climate data, and we also used importing the matplotlib.pyplot as PLT for plotting the graphs visualization purpose. And we also use the Flask, imported the Flask, which powers the web app, handles the user requests and renders the HTML. Here, the Flask app setup, we can see this in one line. The Flask app setup is done here, which initializes the Flask app first and points to that particular template folder where the HTML files are in, and it also points to the static folder where the CSS files are in. Then it loads the data once at a startup, which means here it loads the all our climate data into that particular pandas frame, and it extracts the list of cities, unique cities, the dot unique function, which extracts that particular unique city names in the drop down menu in a sorted order. And after that, we are defining a function which is named as plot to base 64 of figure, which means it converts that particular plot to the base 64 size by and it's also save figure function here, which saves that particular figure in a PNG format in a tight uh, inches to the base 64. And after that, image of base 64, which that converted into base 64 code, and it also reads and decodes that particular characters. And the close figure, which means it closes the figure to the free memory. Next part will be continued by Arpita.
Generated was defines a function of connect person and makes simple daily just like city. It should be a string representing the name of the city for which the parts will be generated. And the next line of the city which filters the data frame here to include only those where the value in the city column is just the new city. Dot copy is used to create a separate copy to filter the data frame to avoid modifying the original. And the next line, city tier is equal to city dot to group by the year. And here the groups the data by the year column. For each year, it calculates the mean of the numeric column like temperature, rainfall, etc. Has the index is equal to false, ensures that the year remains a column, not the index. Numeric only is equal to true ensures only numeric columns are averaged, which presents error. And the shorts and the city is equal to city def is equal to city df dot sort. Here the sorts the data frame in ascending order of the year, so the plots appear chronologically. And the plots initialize an empty list of plots to store the generated plots images in base 64 format. And next line creates a new figure and access object for the plotting using matplotlib. The figure size is equal to 8,4, sets the width and height of the plot in inches. And next, ax dot plot plots the line graph with x-axis, which is represented by the year, and the y-axis, which is represented by average temperature in degrees Celsius. And the graph is marked by like circular marker for each data point, and that circle is colored with the red, gives the line of the markers a red color. And the next sets the title and set the title as the average temperature over the years in cities. And the x label is equal to year, y label is also average temperature in degrees Celsius, and has ax dot grid to adds the grid to plot for better readability. Pause dot append plot to base 64 of figure converts the figure FIG into the base 64 string using the custom function plot to base 64. Appends the base 64 encoded image to the plots list. And next, figure.ax is equal to plot plt.subplots figure is equal to 8,4 creates another figure and access for the second plot, this one for rainfall. And next, the next part is for the rainfall, which is marked by S, which means it marks as the square, and it will be represented by the blue color. And next label, next is of the rainfall overview, and X label it is represented by the year, and the Y label it is represented by the rainfall in millimeter, and the grid is equal to true enables the grid lines, and the plots dot append of plot to base 64 figure converts the rainfall plot to base 64 and adds into the plots list, and the next will be continued by Amrita.
The next part is CO2 emission plot. Figure comma AX is equal to plot dot subplot of figure size is equal to 8 comma 4. AX dot plot of city DF year city DF CO2 emission in terms of tons per capita. Marker is color is equal to green. It means create the figure and act and axis of plotting. The figure size is 8 inches wide and 4 inches tall. AX plot dot means plot the year versus CO2 emission per capita using green color. Next, AX dot set title F CO2 emission over the years in cities. Set the title plot dynamically based on selected city. AX dot set X label as a year. AX dot set Y label as CO2 emission tons. AX dot grid is grid of true. Label of X axis is year. Label of Y axis CO2 emission in terms of tons capita. And AX dot grid is add a grid line for better readability. Next, plot dot append float to base 64 figure. It converts the float to the base 64 encode image using helper function, and it is trending in HTML. Returns float. It returns the list of the floats. Next, a tab dot route methods get and post def index. It means the home router of the Flags app except both get and post method. Next, select the cities is equal to none. Plot is equals to none. Initialize the empty values. Next, if the request dot method is equal to post, select the city is equal to request dot gets of the city. It is user submit from example selected cities. The server read the selected cities from data. Next, if the select city in cities plot is equal to generate the plot of city selected. If the selected city is valid, it generate the plot by calling. Next, return the render template of index.html cities is equal to cities plot is equal to plot. It means regardless of the method, it renders index.html passing cities list of the available cities names plots list of the plot image. Next, if the name is equal to main app dot run of debug is equal to do, it means the script is run directly. It start more than
Results will be like after running that particular code, we'll get the output like this. In this particular web page, the output will be seen like this. We have created this web page by using the HTML markup language, and we have designed this web page by adding some colors and drop down menu, which is of what by using CSS. And here the drop down menu will be given like which is the list of Karnataka cities, and visualize where we what which cities you want to get the data of rainfall, carbon dioxide emissions, and the temperature. You can select the city and get the visualization of each city. Here I'm going. Which is named as visualize. Then he will be get the output like this: the average temperature overs in the Davangere and the average carbon dioxide emission over years in the Davangere, and then average rainfall over the years in the Davangere from 2000 to 2020. The user will be displayed like this, and after that it will be continued by Arpita.
Here is the primary output of our project. Here, the user can make input of the desired cities like Bellary, Belgavi, Bangalore, Davangere, Mumbai, Kalburgi, Mangalore, Mysore, Shimoga, Tumakuru, and the user city selection, interactive city selection, user input in Google Colab. User is shown a list of available Karnataka cities. City is selected through a text input in Colab. The code validates the city name and filters data accordingly, enhances interactivity and personalizes a result. And the graph is shown like this. The title of the graph is title of the graph is average temperature over the year in Bangalore. An average temperature here from 2000 to 2020. Here the average of all the temperature of the vendor is collected and it is plotted as the graph. And the next output is of CO2 emission was the years in Bengaluru. Here, the green marks will suggest that how the average of the CO2 emission over the years in Bengaluru. Here, the next slide is of learning and challenges. Here, understood climate data structures like CSV, learn how climate data is stored in a tabular form and read using the Python, improved Python skills like pandas, matplotlib, and cpop, gained hands-on experience with the real-world data analysis and visual libraries, learn to pre-process the real-world data, face challenges like missing values or inconsistent data and cleaned it for the analysis, and develop teamwork and task-sharing abilities. Each member likely took different roles, coding, research, presentation, etc., improving collaboration. And the next part is continued by Amrita.
The next part is conclusion. So we can successfully collected and visualize 13 years of climate data and then create the graph for temperature, rainfall, and CO2s. Highlighted Karnataka's climate trends and delivered full PBL reports and presentation as the team. Next part is continued by Kirtana.
Here we'll see the future improvements that what we can do in future, that expand where we can expand a particular project by using these points, like automate the data collection via APIs, which means we can also connect that particular APIs to automatically update the data, so we don't need to have to download that particular files manually like CSV and other. And we can build the interactive dashboards by using the Plotly or Streamlit to create an interactive dashboards, interactive graphs where users can select their cities, and she can select their years what they want, and we can zoom in too. And after that, add the comparison with the other states or countries. Like beyond the Karnataka cities, we can also expand this project to compare the Karnataka cities climate data with other states or countries and etc. And we'll also integrate the satellite imagery for higher accuracy, which means we can add the satellite data for more accurate and detailed climate insights. So this is what our project. In conclusion, we'll see that through this project, we successfully collected and processed and visualized the 30 years of climate data for Karnataka cities, and we highlighted the key trends in the temperature, rainfall, and carbon dioxide emissions, and learn how the data is going to be. Science helps in science and understand the climate change, and it also identifies the ways to improve our work in the future, like adding APIs and interactive dashboards and the satellite data. Thank you for everything, and we look forward. Thank you so much.